All right, so today I am doing this live session on modeling with systems. So this is basically word problems with systems of equations. And I'm going to be doing a problem that is similar to one that you have on the assignment for this week. So this will be very helpful if you have not yet done the assignment. So I've just got a few examples. I'm not going to solve all of them because the biggest part is understanding how to get the equation. Solving from there is usually pretty straightforward for people, but I will go through at least one example of solving. Okay, so here's my first example. Weights of atoms and molecules are measured in atomic mass units. A molecule of ethane is made up of 2 carbon atoms and 6 hydrogen atoms and weighs 30.069 atomic mass units. A molecule of propane is made up of 3 carbon atoms and 8 hydrogen atoms and weighs 44.096 atomic mass units. Find the weights of a carbon atom and a hydrogen atom. So this is actually an example of something that you do in chemistry, and this is how systems of equations and algebra basically relates to chemistry. So the first thing to do is to set up your equation, or your 2 equations. And you're going to have an equation for methane or ethane and then for propane, because it's basically an equation for each different situation. And the way that this is set up is it lends itself very easy to figuring out the equation. So basically, if we first need to pick our variables, so let's say C is going to be the weight of a carbon atom, because that's what we're looking for. And then the other thing we're looking for is the weight of a hydrogen atom. Now I actually know what these are because whoops, I should just say weight of hydrogen atom. I mean, you don't even need to solve this to figure it out because this is a real problem and it's basically the answers that are on the periodic table, but we can get it even without that. We're going to show how you can use algebra to figure this out. So I've got my variables, C for the carbon atom, H for hydrogen. So I'm using the letters to make sense, that kind of match with what they stand for. And then I've got for my equation. So for ethane, we have 2 carbon and 6 hydrogen, and then that equals 30.069. So 2 carbon atoms, if you have a weight of 1 carbon atom, you 2 of them multiply by 2, and then you're multiplying the weight of hydrogen by how many you have. The second equation is propane, and that one is 3 carbon and 8 hydrogen, and that gives us 44.096. Now, to make this a system, you have to have the curly braces around the equations to indicate that these are taken together. So now we want to solve the system of equations. When I have my variables on the same side, I tend to solve this by elimination. And so I'm going, just looking at my numbers, I got C, 2C, 3C. I can make the C's to be 6 and -6, fairly simple. Otherwise, if I'm looking at the 6 and the 8, I can make those equal 24. That's a little bigger. So I try to pick the smallest one. And so I'm going to choose to eliminate the C and make them 6C and -6C, so I can eliminate those. So it doesn't matter which one is which. I'll just say I'll multiply the first equation by -3 and the second equation by 2. So that will give me -6C minus 18H equals, and now, of course, I need my calculator here. -90.207, and then 6C plus 16H equals 88.192. So for the elimination process, once you have variables with that have the same coefficient opposite signs, we add the equations together. So -6 plus 6 is 0. So now my C is gone. And then I get -2H equals negative 2.015. And then I divide both sides by negative 2 to get me the weight of hydrogen at 1.0075. Now I need to find the weight of both carbon and hydrogen, so now I need to plug that back into one of the equations so that I can find what carbon is. So it doesn't matter which one I plug it into. I'm going to plug it into the bottom one just because that's where I have space. So that would be 3C plus 8 times 1.0075 equals 44.096. So multiply, it's going to be 3C plus 8.06. Subtract, I get 3C equal to 36.036. And then when I divide by 3, I get C equals 12.012. And that is the weight of a carbon atom. And you can verify that with the periodic table. Carbon is 12, hydrogen is 1. So that's an example of elimination. And getting the equation itself was fairly simple. It was just a matter of reading it almost exactly off of the problem itself. Okay, now here's example 2, and this one's a little trickier. Connecting a DVD player to a television set requires a cable with special connectors at both ends. You buy a 6-foot cable for $15.50 and a 3-foot cable for $10.25. Assuming that the cost of a cable is the sum of the cost of the 2 connectors and the cost of the cable itself, what is the cost of a 4-foot cable? So this one's a little tricky because we're looking for the total cost of a specific length of cable, but it's made up of different parts. So our cost of a cable is equal to 2 connectors plus the length, which would be however much we need times the price per foot. Because the length is going to, how much the length of cable costs will depend on how long the cable itself is. So we've got 2 connectors, whatever the connector costs, and then how much the length costs. Now, we're given 2 costs for cables, but we don't know how much a connector costs, and we don't know what the price per foot costs. So those are going to be our variables. So let's say I say connector is C, and then price per foot, let's just use L for the length for the cable. I would normally use C for cable, but that is also being used for connectors. So I'll just use L. And I'm using a capital L so that it doesn't look like a 1. And so that way my variables look pretty clear. So we have a 6-foot cable. So the cost of the 6-foot cable is $15.50. And that is made up of 2 connectors. So all of these are made up of 2 connectors. And then we have 6 feet times how much it costs for basically 1 foot of cable. Then we have a 3-foot cable. So that's $10.25. That is also 2 connectors. And then that is 3 feet times the cost of a foot of cable. So now that gives us our system of equations that we can solve to figure out what the cost of a connector is, and then what the cost of a foot of cable is. So this is another one that I would solve by elimination, and it's fairly simple because you can just multiply one of the equations by negative, and then you can go through. So because this one is so simple, if I just multiply the second equation by -1, I'm basically just changing all the signs. So I have 1550 minus 1025. So I get 525. The 2C minus 2C cancels, and that gives us 3L. So then I need to divide that by 3, and that gives me 175 as the cost of a length of cable. So 1 foot of cable is $1.75. And then we need to find out how much a connector costs, so I can plug that into the equation. So let's say I plug that into the first equation. So I'm plugging that in for L. Now, I'm not going to show all of the steps here. I will let you verify that you get this answer, just because I'm trying to conserve space here. But you get 250 equals C. So the cost of a connector is 250. It's actually more than the cost of a foot of cable. So now we know how much a cable, the foot of cable costs. We know how much the cost of a connector is. Our question says, what is the cost of a 4-foot cable? So if we have 4 feet of cable, that's 2 connectors plus 4 times the length of, or the cost of a foot of cable. So that's 2 times 250 plus 4 times 175. And that comes out to $12. And so then we know that a 4-foot cable is $12. This example, this is one that is similar to number 4 on the week 2 assignment. So this one is really important. We have a mixture of 6 gallons of chemical A, 8 gallons of chemical B, and 13 gallons of chemical C, and it's required to kill a destructive crop insect. Commercial spray X contains 1, 2, and 2 parts respectively of these chemicals. Commercial spray Y contains only chemical C. Commercial spray Z contains chemicals A, B, and C in equal amounts. How much of each type of spray gives the desired mixture? Okay, so we have lots of things going on here, a lot of unknowns. We don't know, we have A, B, and C, and then we have X, Y, and Z. And we're dealing with parts. We know how many gallons we need of each one, but we don't know, and we know the ratios of each one. So what makes this one make more sense is by making a table. Because otherwise it's really confusing. The first time I did a problem like this, I actually got it wrong because I was not looking at it the right way. So let's make a table. And this is going to be similar to a mixture problem. So if you remember, if you've done any kind of mixture problems in the past, you usually have the things you're mixing together. And so we are mixing together A, B, and C, and then we're getting a mixture. And then you have these columns, and usually the mixture problems would have the amount that you're mixing times the percent that you were mixing. And then then you kind of multiply those together. Well, we don't know the amounts of, and we know how much of A, but we don't know how much of X, Y, and Z are in each of those. So those are the unknowns. But we do know the parts that we are mixing together, or the percentage, because it tells us how many parts out of each of these. And so I'm going to put columns of X, Y, and Z. And these will give us our 3 equations. Because if you have 3 variables, you're going to have 3 equations. So, okay, so let's look at chemical A. So chemical A, we have 6 gallons. So I'm going to say, we're assuming we're using all of the, basically, so we've got 6 gallons. Oops. I have my A, B's, and C's. A, B, C. Okay, I have this backwards. Whoops, erased too much. I put my mixture, made my table in the wrong spot. Okay, and then I'm going to just put the total here. Okay. So we have 6 gallons of A, 8 gallons of B, 13 gallons of C. So those are the total gallons that we have. Okay, so commercial spray X contains 1, 2, and 2 parts of each chemical. So if you add up how many parts you have, that's 5 parts. So we have 1 part of A. So that's going to be 1/5. And then we have 2 parts of B, so that's 2/5. And then 2 parts of C. So that is 2/5 again. And so we do the part times the amount of chemical. We don't know how much. So each of these are going to be multiplied by X. Basically the part times the variable. Now, Y. Okay, so commercial spray Y contains only chemical C. So that is just C, and then we have 0 out of these others. So the whole thing is C. Now Z, commercial spray Z, contains A, B, and C in equal amounts. So if they're equal, then you're dividing it by 3. So you have 1/3 of each. That's 1/3. Whoops. 1/3 and 1/3. And so now going across, this gives me my equations. 1/5 of chemical A comes from X. I'm going to skip the 0. And 1/3 of chemical A comes from Z. And I need 6 gallons total. 2/5 of chemical B comes from X. And 1/3 of chemical B comes from C. And I need 8 gallons total. Then we have 2/5 of chemical C comes from X. A whole part comes from Y, and 1/3 comes from Z, and that gives us 13. And that will give us your 3 equations. And when you solve for X, Y, and Z, those are going to tell you the number of gallons you need of each commercial spray in order to get the right chemical balance that you want. So the hardest thing about this, and I even confused myself initially when I set this up, is that the question is, are your variables the A, B, and C, or the X, Y, and Z? So because they're giving us how many total gallons we need of A, B, and C, that means our variables are going to be X, Y, and Z. If they give us the total of X, Y, and Z, then your variables would be A, B, and C. So I had initially switched my setup, and because I had initially thought it backwards, which is actually very common and what you will probably end up doing too. So this is a very tricky problem. But once you have the setup, then you can go ahead and solve using the techniques that we have learned this week. So if you have any questions, you can give me a call. Here's my email address. And my phone number. And I look forward to hearing from you.